Greetings of the day, dear students. Let's start again with our chapter some important chemical compounds, and in that today we will go to discuss about compounds. We already learned what is the meaning of element. In our previous class we already saw that an element is the any name that is given to an atom, like hydrogen, helium, lithium, boron, carbon. These all are actually elements. Then we discussed what are molecules. When two elements which are same, like oxygen oxygen or hydrogen hydrogen, they combine together, they form molecules. We learned what are molecules, and now today we are starting with compounds. Now what are compounds? These are just like molecules, but the only difference is that in element all the atoms are same. We know that in that elements, all elements are same in a molecule, but in a compound the elements are different. As we discussed in our live class, this is an example of water. Here you can see there are two different elements. The one is oxygen over here and the another are hydrogen and hydrogen. Now you can see over here that this oxygen element is actually different from this hydrogen and this hydrogen elements. That's why we say that these are called compounds. Now let's see another thing. Students, you need to learn the examples of the compounds which are very important. Now let's see what are the examples of the compounds. First example is water, second is sodium chloride or NaCl. Now the two atoms combine with each other, and these can combine through more than two bonds also. Like in this example, oxygen is combined with hydrogen with a single bond. This is a bond between the two atoms. Similarly is over here. But in some of the compounds we see that they are connected through two or three bonds also. They are pure substances and cannot be broken by simple methods. If we try to break this water molecule into hydrogen and oxygen, we are unable to break it. The main reason is that because these are stable. Now students, let's discuss an important compound, water. Now students, it is a V-shaped bent molecule that we have already discussed in our first chapter, and since its chemical formula is H2O, that's why it has three atoms. The oxygen is the negative atom over here in this water molecule, and in the previous one we saw this oxygen is negative and it is larger in size because it has accepted the electrons. Hydrogen is positive. Under some chemical conditions, water molecule is broken to form one atom of oxygen and two atoms of hydrogen. I already told you that the compounds are difficult to break, but if we provide them suitable chemical conditions, then we can see that they are easily breakable into their respective atoms. This H2O breaks into H2 and O. Now this is an important reaction which you need to learn. Now there are two bonds. In water molecule we see that first bond is this and the second bond is this. That's why there are two bonds. In your further classes you will read how to balance this given equation, because I already told you this oxygen cannot exist single because of the electrons it have. It is reactive. That's why we need to balance it in such a way that everything over here formed and over here that are already present is stable. We are not learning it right now, but in the next class we will surely learn. Students, the second reaction of water is when we add salt in water. We have often seen the experiments in which we are adding salt to water. That time we get salty water. The actual formula is not possible, but if we see when we combine water and salt, we get this type of product, and this is only the salty water. H2O in bracket and NaCl in bracket, and they are written together. So this is the whole theory of water which you need to learn and important for board examinations. Let's see sodium chloride. Students, this is the common salt or sodium chloride, and it is widely used in the food we eat. This is sodium chloride that we already know. and we have discussed in our first chapter. You can see it has two type of atoms. The first is cation or sodium, which is positive. Second is anion or chlorine, which is negative. This has a straight chain structure. We already know NaCl has a straight chain structure. It does not react, yet on chemical reaction it gives atom of chlorine and sodium. Why it does not react? Because it is a compound, and compound is stable. Now when we try to break it under chemical conditions, we get Na plus Cl. We also write the charges over here. On Na we write positive charge, and on Cl we write negative charge, because Na is always positive, Cl is always negative. This Na word is derived from natrium, which is a Latin word for sodium. Note that charges are denoted by on the atoms also. Now let's see carbon dioxide, another important compound. We know that carbon dioxide is found 0.02% in nature, and it is exhaled by us. We inhale or take in oxygen, and we take out carbon dioxide, and it is inhaled or taken in by plants. It is a triatomic molecule since CO2, so there is one carbon and two oxygen atoms. That's why we say it is a triatomic molecule. On chemical conditions, when we break, we get one carbon atom because it has one carbon atom only and the two oxygen atoms. The chlorine is written over here wrong. Now carbon dioxide on reaction with water form one acid. This is the acid which is very important. This is H2CO3. You need to learn the name of this acid, but you need to learn this reaction. It is very important. H2O, when combined with carbon dioxide or CO2, it forms H2CO3. Let's count the atoms. There is one rule in chemistry that always the atoms afterwards and before are always equal. In this case, let's see. Here are two hydrogen atoms. Here are also two hydrogen atoms in it. Here is one carbon atom, and here is also one carbon atom. Here are three oxygen atoms, and here 2 plus 1, 3 oxygen atoms. That's why we say that this reaction is correct, because the atoms are equal. Now you can see the structure of carbon dioxide. As we saw that in NaCl there is only one bond between sodium and chlorine. In carbon dioxide we see there are two bonds between this and two bonds between this. That's why it has 4 bonds and it has a straight chain. Let's discuss ammonia. We do not know much about this compound, but we can know that it has a pungent smell. It is excreted out with excreta, and that's why we study this, as it is a very important compound and it has this type of structure. Note that ammonia has 4 atoms, 1 nitrogen and 1, 2, 3 hydrogen, means 1 plus 3, that is total 4. It has a pungent smell, and it is a tetraatomic compound. Tetraatomic means 4 atoms, and it has 1 nitrogen atom and 3 hydrogen atoms. Please note the formula of ammonia is NH3, N 1 nitrogen and 3 hydrogen, that's why NH3. That's all for the day, students. Thank you and have a nice day. Also, please learn the reactions. These are very important for your board examinations. Thank you.